Hi. My name is Jamie. I'm an engineer at Honeycomb.
And my name is Yuri, and I'm a co-founder of OllyGarden.
And what we want to talk to you about today is a life of a span. We have a little bit of a silly story to tell. We want to illustrate an OpenTelemetry span's journey from code to cloud. So spoiler alert, there are multiple spans involved. That helps us tell the story of a trace as well. But we're hoping you can have some fun with us and just also learn a little bit of something along the way. But definitely expect some silliness. So as you can see from the agenda here, the main parts to be covered look a lot like a lifetime. So we have the birth of a span, and we have that span growing up, making friends. Along the way, they're journaling their memories, eventually leaving home, and then leaving their legacy.
So let's talk about the birth of a span. Meet Spanly. This is, the name that we try to figure out our hero in our history. So Spanly's mission is basically bringing visibility into what your distributed system is doing. So Spanly is born when your application starts a span using the OpenTelemetry tracer. He's given a resource, attributes that will describe his life, like service name and host name. Along with other metadata, he's also given a trace ID and a span ID. That's what you might have in your own application as well, and sometimes of the same structure will be there. So, as you can see here, we have the Spanly birth certificate with the service name, the name, and trace ID, and other attributes. So, we said Spanly came from a tracer. The tracer is part of the OpenTelemetry SDK. Think of it as a midwife who brings spans into the world. Sorry for that. A span is born when our trust friend and the midwife, the tracer, sorry to name a tracer like midwife, helps bring it to life. Or more practically, invokes the tracer.startSpan as a parameter and the operation name. So this span's creation could be done manually for a custom piece of business logic, or it could be created from an instrumentation library in different languages, Python, Node.js, and so on. The mechanisms are generally the same. Acquire the tracer and start the span with the name of the operation, like const span equals tracer start span, and this is how the journey starts. The tracer initializes the span with crucial metadata like span name, start, timestamp, or the trace ID. So here is what the span may look like after it was born, like name, Spanly, kind 2, and the start time that Spanly was born. So after this first step that our hero Spanly was born, it starts growing up. Jamie.
So as Spanly grows up, he likes to journal about his life. The journal is going to be the story of his life, and it plays a big role in most of this talk because it helps go through some of the things we want to explain. Spanly is not overly verbose, as you can see, but he does have his daily gratitude journal where he'll say things like, mood is happy, and the weather is sunny. And so these observations can often be represented as key value pairs, which can then be added to a span as attributes. So attributes are just that. They're key value pairs that can describe a span, a piece of logic, current situation. So for Spanly, that's something like weather is sunny. For you, that may be something more like a team name is alpha or operation name is expensive operation. But you add them to a currently active span to help describe what's happening at any point in your process. And for Spanly's upbringing, there's some structure in place already. Like he goes to school. The school system puts him in a particular grade, gives him an age 7, grade 2. So they automatically assign those attributes to him that gives him that structure as he's going through. And you might find that you're trying to describe everything, you're giving these names to these attributes, but you might find that you want to be a little bit more consistent over time. You want to be able to reach for the same attributes, the same names, so that you and your other teams are sort of speaking the same language. And that's where semantic conventions come in. If you were listening to the keynote earlier, they talked about how important semantic conventions are. And they just define standards for generating consistent, accessible telemetry across a variety of domains. So again, whether it's Node.js, Python, Java, the idea is that we can have the same attribute names that are consistent across these languages. So for example, an instrumentation library that records HTTP requests will have attributes that represent that request. They are added for you when you're using that instrumentation library. So you'll see things like http.request.method and http.response.status code. And again, those are supposed to be the same across various languages. So in addition to Spanley's gratitude journal, he also likes to log about life events. So for example, maybe he got a good grade on his report card, or he went to the amusement park. The idea of these events are exactly what they sound like. They are events. They are things that happen at a particular moment in time in your application. They're structured logs that are going to have a name of what happened. They don't have a duration like a span does, but they are associated with that span. So while Spanley's events may be things like went on a roller coaster, your event might be specific to your business logic. User clicked a button or a task completed at a particular time. This is as simple as span.addEvent and the name of the event. I don't know if that sounded weird. And finally, life isn't always smooth. When things go wrong, Spanley may encounter a problem that gets recorded, like a bruised knee or a temper tantrum. Errors and exceptions are part of his story too, just like it is in ours. Sometimes Spanley gets into trouble and he gets put into timeout. That is also recorded in his life story. So they're part of his story and they're common in your applications too, right? So we want to be able to indicate when a problem occurs in our application. So you might have a timeout like Spanley did, or there may be something else that happened and you end up with a stack trace or whatever else. So you record these to be able to find them later in your vendor backend, which we'll talk about, but they'll get recorded as an updated span status with an error code for your span status and an exception.
And Spanley grew up, and it starts making new friends. So Spanley meets other spans along the way, both siblings and children. Each introduction involves a passing of context. Yeah, let's talk about the context propagation. Yeah, and it could be, the context propagation, it could be like leaving a handprint on your heart. So this is how Spanley keeps track of his lineage. He meets friends by passing headers through services. When Spanley's new friend, Tracy, it's a good name, right? Goes to a dinner party and is asked, how would you meet Ollie? Ollie, it's another Spanley's friend. And Tracy shares that she met Ollie through Spanley. So context propagation can be a tricky topic. The basic idea is that information from a span is passed to the next created spans. Information include things like trace ID, span ID, and also headers using the W3C trace context. This helps show how each span is connected. You can also think of it as a family tree passing genes down, like Spanley, Spanley Jr., or Tracy. And Tracy is a parent of Ollie and Spandrill. Well, sorry for that. Yeah. And another example of trace parent, as you can see here, the IDs of each one, the parent ID, and also the trace ID for each of them. So, also, regarding the notice the two spans, the span ID and the trace ID of the first span was passed into the next span. So the span is created with a new span ID, but keeps the same trace ID and uses the span ID of the first span to set its parent span ID. Even reading and explaining is hard, right? But it's basically doing this fingerprint, okay? That or propagating this fingerprint. That's how we can tell later that one caused the other. So Spanley made new friends, and it's time to journaling memories.
Right. So we talked about how Spanley has been having this journal that he's keeping track of everything, daily gratitude, the logs of each day, big events that happen. And so throughout his lifetime, he's been able to rely on that journal to go back through those life events, to remember what had gone on. And he starts realizing his life is pretty neat, and someone might want to hear about it. Surely this is a really interesting story. So as he starts reaching the end of his life, he prepares to get his journal ready for publication. He realizes more people need to know about Spanley's life. So the journal holds a record of all of Spanley's shenanigans, his relationships with other spans, all the life events that he's had. He has filled his journal all the way to the very last page to make sure that not a page is wasted. The adventures are sitting idle in the journal, waiting to be shared. And the journalists that he talked to tell him that he needs to have everything ready so they can review it all at once. They're not interested in just getting a section from his journal here and there at various times as they happen. So we can liken this to a simple span processor and a batch span processor. A simple span processor processes spans one by one, immediately. As they are generated, they're immediately processed to be exported. And this is not what the journalists want from Spanley. They want to have everything batched together before getting it handed off. And that's what the batch span processor is for. It reduces overhead, improves performance, and generally makes things a lot easier so that instead of going one by one, everything is sitting idle, waiting to go. So much like the entries in Spanley's journal, the spans will sit idle in a queue until a batch reaches an optimal size or a time limit triggers their departure.
So not we, but Spanley made friends, journaled some memories, and it's time to leaving home. What means leaving home? At last, Spanley is headed to the local publisher to get his story published. They've provided a nice car to ensure he gets there with his journal safe and sound. So exporters like the OTLP exporter are like journalists, sending Spanley's story to the backend. These journalists are reviewing Span data, ensuring it's correctly formatted and securely transmitted via protocols like OTLP or zipping. Exporters translate and package each Span's information, make it ready for the back-end processing. Different exporters can send in different formats. For example, there is an OTLP exporter to the HTTP protobuf, gRPC protobuf, and also the HTTP JSON. So an optional stopover would be the collector. The default endpoint for an exporter is localhost, which lines up with the old OpenTelemetry collector defaults with the ports for gRPC and the HTTP. The collector is like a transit hub, and it can further modify, batch, or enrich data before sending them onward. So what is this Span legacy, Jane?
Yeah, so Spanley, while he may be coming to the end of his life, his story is not over. His story is finally going to be published for the world to see. So after that trace is sent through a collector, it's then re-exported to a telemetry backend, like Honeycomb or Jaeger. And this is where his story lives on. So what we can see here, which we'll go through in a moment, is a complete trace that represents Spanley's life. So these backends show the entire trace, which lets us see the relationship between the spans, which represents as making friends, the events that occurred along the way that are associated with each span, and the errors and exceptions. And so if we look here, we can see trace propagation with those span IDs and parent IDs. We can see these events, little dots representing life events. And there's a span with an error, where we can see where Spanley was put into timeout. So trying to see those a little bit closer here, we can see a moment where Spanley says hello to Tracy, one of his friends that he's made. We have, this is not going, there. Here we can see an error, an exception. This is a controlled learning error. He's having trouble learning something, and this is how that might show up with your span.
Yeah. So what we learned about the Spanley's life, it is the birth of a span happens with a tracer. And the phase of the Spanley made new friends means the context propagation, because Spanley made new friends telling them, hey, look, I'm here and I have something to pass to you. The phase of Spanley that started growing up means in the distributed tracing area, the adding attributes, enriching the data, logging events, and so on. And about the journaling memories, it's about the span processing. Leaving home, it's the phase that Spanley got exported, and the Spanley's legacy is about the visualization. You, as an observability engineer, are most interested to see how looks like all the Spanley's legacy. So here's a list of further resources that you can check about the semantic conventions, about the instrumentation using, for example, Node.js, or our slides as well, the life of a span. Yeah, thank you, Jamie, for putting this on the GitHub. And thank you. And if you have time, please, we appreciate your feedback.
Hold that thought. Okay.
Yeah.
Any questions?
I have to ask.
Yes.
Unsampled span, is it a stillburst one?
Oh, God. That sounds awful. I don't know if I want to repeat that. But I love the creativity.
Yeah, it was amazing. What was the question? There.
You don't want to disappoint the audience.
I have another terrible question. If the car crashes on the way, did Spanley exist at all?
So I guess there's various things that can happen. These are very morbid questions at the end of what we were hoping was a more lighthearted story. Different things can happen to Spanley along his journey, though. So for example, if he is trying to make friends and there's a problem, we might end up finding out that, hey, I actually don't know how I know Spanley. So that's where we have those breaks in our context propagation, is when you end up seeing something like a missing span, where something says that it has a parent span, but that never arrived where it was supposed to. So that is one thing that can happen. Also, we talked about having the collector, which is an in-between stop. That's one more place where something could technically get lost. But the collector works by being able to take in a lot of data. And so ideally, that's offloaded there and then gets sent on to their backend.
Oh, hey, we were talking about this this morning, but what's the most reliable way to know the duration of Spanley's life? Like, is it the visualization tool that has to figure that out based on all the spans, or can you rely on just the root span, the father?
Yeah. Did you want to? Okay. Yeah, so what we can see is the root span ends up getting sent last. That's when everything is now batched up and sent together. So we should be able to see from that root span how long everything is from start to finish. So whether you want to see that in the UI or if it's something that you want to export, say, to a file and you're doing something else with it. But that's generally going to be a way to see from start to finish how things go. It gets a little bit interesting when you start having like async operations and things like that. Or occasionally I've seen like events that occur before a trace occurs. And that's always a little bit weird. It's like it's kicked off that trace. But generally speaking, you should be able to see the full duration from the top. And as you go down, you can see each individual piece, how long those things take, how long those particular processes take. Does that answer your question? Okay.
This might be somewhat of a basic question, but how does you kind of breeze through?
Here, hold on. This might be somewhat of a basic question, but you kind of breeze through real quickly the context being passed. So if you're working in microservices, you could be fully separate containers that are running different pieces that are part of his life. How do those get propagated?
Sure. So What we have is, so with context propagation, we have this W3C trace context. And so what happens is there are headers, special headers that get passed, and they're carried, there's a context carrier, I guess, that is going to carry that from one to the next. So what's nice is if you're using OpenTelemetry, the default is going to be this trace context and baggage headers. And so it will propagate for you, or alternatively, what you can do is when you start a new service, you can manually extract from the headers that are passed in and continue a trace from there by then injecting the headers that were pulled out of the request that got there. So you'll end up seeing, there's definitely some examples on the public docs for sure. It can be a little bit tricky, but things like automatic instrumentation or ensuring that you're using the same trace context amongst these different services should make that easier for you.
So if you use some of this instrumentation in both, in these several services, and you make a call from one service to the other, there's some intelligence there that it, I know within that one service, it's able to kind of find its way through all the node calls, let's say, but the instrumentation can also help you find the connection between the two different services.
Right, so for example, I can have a service that the front end is written in Node, which then calls a Python service, which then calls a Go service. And these could all be instrumented with OpenTelemetry, and we'll end up seeing a trace at the end for each of those languages that still represent the entire trace.
Thanks.
I think we might be at time. But we'll be around all day, so if you want to come find us, happy to talk more about Spanly.
Yeah.